Welcome to this podcast on an integrated scenario. This will involve a discussion about a particular scenario which will be discussed in the podcast, and all the questions will be related to the hardware, software, internet and networking, data and information, and solution development related and applied to this integrated scenario. These topics are from question 6 of the 2024 Information Technology November Paper 2 exam or theory exam. There are 3 ways that you can engage with the content of this podcast. If you want to test your knowledge, then download the questions covered in the video first. The link to the PDF is in the video description. Then go and attempt those questions, and finally come back and listen to the podcast so that you can compare the discussion with your answers. If you want to use the podcast to learn new information, then first listen to the discussion, then download the questions, the PDF link in the video description mentioned earlier, and then test yourself to see how much you remember from the discussion. Or you can simply enjoy the discussion and learn more about how the different forms of computing can be applied to this integrated scenario. And now let's hear what our podcasters have to say about this particular scenario.
Welcome to the deep dive. Today we are putting on our operational hats, taking a look at a huge integrated ICT system, the kind built for something like a marathon organizing committee. Yeah, this isn't just theory. We're diving deep into a real-world scenario, a system managing everything from registration and race tracking to team collaboration and serious security for thousands of people. So if you're studying computer science, this is like the perfect case study. It shows how all those concepts you learn, certificates, distributed computing, metalware actually play out under pressure, and importantly, where things can go wrong. Okay, let's unpack this. Our mission: to look past the basic definitions and really focus on the tech trade-offs, the security weak spots, and, well, the operational risks involved in running such a massive event.
It really is fascinating. You've got all these different technologies, hardware like RFID tags, sensors and wearables, complex software, networks, and they all have to work together perfectly. It creates amazing efficiency, sure, but also some really complex challenges: security, ethics, usability. We're going to connect those textbook ideas directly to this high-stakes, real-life race day situation.
Right. Let's start right at the beginning for any runner. The registration website. Trust is everything here, isn't it? You're entering personal details, payment info. So what are those absolute must-have visual signs that tell a user, okay, this site is legit, it's secure?
Yeah, those trust signals need to be instant and clear. First thing, always look for HTTPS at the start of the web address. That S means secure socket layer is active.
The S for secure. Got it.
Exactly. Then you've got the padlock icon, usually right there in the browser bar. Some browsers might even turn the address bar green for extra assurance. But, for students digging deeper into IT, the real key isn't just seeing the lock icon. It's knowing you can actually click on it or nearby to view the site's SSL or digital certificate.
The certificate itself. That's the underlying proof. Right. So let's talk about that. Textbooks explain SSL with public and private keys for encryption. Simple enough. But here's where it gets really interesting. How does the system guarantee that certificate is trustworthy? And what happens if that trust fails?
That's the crucial part. The trust comes from something called a certificate authority, or CA, the trusted third party. When the Marathon Committee gets their SSL certificate, the CA has verified their identity. So yes, the public key encrypts the data, the private key decrypts it. That's the mechanics.
Okay.
But the trust chain is what proves the certificate is authentic and belongs to who it says it does.
Yeah.
If that certificate expires, or even worse, if the CA finds out the site's been compromised and they revoke the certificate.
Ooh, revoke. That sounds bad.
It is. Your browser will throw up a big, scary warning. It basically stops people from accessing the site. Imagine the chaos if that happened mid-registration season for the marathon. Huge reputational damage, financial loss, all because of a certificate issue.
Wow. Okay, so it's not just the encryption tech, it's the whole validation process behind it. Really critical. Okay, moving from securing user data to securing the race itself. Let's talk about those little RFID tags they give to every runner. How does that tiny chip actually determine a runner's precise marathon time, and what problems does it solve?
Well, each RFID tag has a unique ID number, and that's linked specifically to one runner in the system. As the runner crosses special mats at the start line, finish line, maybe some checkpoints along the course, readers in those mats pick up the tag signal automatically.
Automatically, okay.
Yes, and it records the exact timestamp. This automated system is vital. It gets rid of the need for manual timing, which can be slow and, frankly, prone to human error.
Makes sense. But the source material mentions some athletes, especially the elites, are a bit skeptical about these tags. If it's so precise and automated, why the skepticism? Is it just privacy, or is there a technical challenge?
It's often about the specifics of timing. You've got two key times. Gun time, which is when the starting pistol fires for everyone,
Right, the official start?
and chip time, which starts the moment your specific tag crosses the starting line mat. Elite runners are usually ranked by gun time. Their chip time is more for their personal record. The skepticism can sometimes stem from the sheer scale. Imagine thousands of tags crossing mats almost simultaneously. There's always a slight technical concern about potential signal interference or a missed read, however small the chance.
Okay. Potential for errors in a high-density environment.
Exactly. But for the vast majority of runners, the benefits are huge. You get accurate, reliable data for your own performance, and results can be posted online almost instantly. Family and friends can track progress from home in real time. That's a big plus.
Yeah, that real-time tracking is pretty cool. Okay, let's shift to the gear the runners themselves are using. Wearables like the Teklo Pro and FitFlex Ultra. The FitFlex Ultra mentions GPS. We all kind of know GPS uses satellites, but can you break down the mechanics? How does my watch know exactly where I am on the course?
Sure. GPS stands for Global Positioning System. Your device, the watch in this case, is constantly listening for signals from GPS satellites orbiting Earth. It needs to hear from at least 4 different satellites. Each signal contains info about the satellite's location and the current time. By measuring the tiny differences in time it takes to receive these signals,
Tiny differences. Okay.
the device can calculate or triangulate its own position on the globe pretty accurately. That gives you the real-time tracking and mapping on your run. But this does bring up a really important point: ethical considerations.
Right.
A device that's constantly tracking your location, your heart rate, your speed, it raises serious questions. Where is all this sensitive data being stored? How secure is it?
Yeah.
And crucially, could that very specific location info be misused?
Yeah, it's that constant trade-off, isn't it? Convenience and cool data versus privacy and security risks.
Absolutely. And speaking of trade-offs, let's look at the Teklo Pro connecting to a smartphone. Our audience knows Bluetooth, but let's think about power. A marathon takes hours. How does the system decide which type of wireless connection to use to make the battery last? It can't just be full power Bluetooth all the time, right?
Good point. Yeah, you wouldn't want your watch dying halfway through the race because it was constantly blasting data.
Exactly. So they use something called Bluetooth Low Energy, or BLE. It's designed for sending small bits of data infrequently, like a heart rate reading every few seconds or step counts. Uses way less power.
BLE for the small stuff.
Right. Full power Bluetooth might only kick in for bigger tasks, like syncing a whole workout afterwards or maybe changing device settings. The whole system is designed around managing power. It's constantly balancing getting the data from all those internal sensors, measuring steps, heart rate, calories, sleep, whatever, with keeping the battery alive for the duration.
That power issue leads us nicely back to the bigger infrastructure. These wearables, they're powerful, but they have limits. So how does the marathon's overall system use distributed computing to handle all that real-time data pouring in from thousands of runners?
Distributed computing is basically the powerhouse behind the scenes. It means the heavy lifting, the processing power, the data storage isn't all happening on your little watch. It's spread out across multiple external servers and systems, all networked together. This is absolutely essential for handling things like latency.
Latency, the delay, right?
Exactly. Real-time tracking needs near-instant processing. You can't have big delays. Distributed systems also provide fault tolerance. If one server goes down...
Doesn't take the whole system with it.
Precisely. There are backups, redundant processing power across the network. It prevents catastrophic data loss if one part fails. It also connects the wearable to much bigger resources. Think complex AI analysis of performance data or detailed mapping features that the watch chip just couldn't handle on its own. And here's a really interesting detail sometimes seen in these systems. They can sometimes manage resources centrally, maybe even leading to things like shared battery life optimization across connected devices.
Shared battery life. Wow, that really treats the whole network like one single organism, not just separate gadgets. Very cool. Okay, let's pivot from the runner's tech to the organizers. They need to coordinate this massive event. The source mentions they set up a wiki site for collaboration. With so much happening, logistics, medical, security, how does a wiki help the organizing committee manage their own internal information chaos?
A wiki is almost perfect for this kind of scenario. It tackles 2 huge problems in big, fast-moving projects: keeping track of document versions and knowing who changed what the audit trail.
Right, avoids endless email chains with slightly different attachments.
Exactly. It allows loads of people to edit and contribute in real time, all in one central place. You're pooling everyone's knowledge efficiently. And critically, every single change is logged. You know who added what, when they did it. That builds accountability and makes the information more reliable. Plus, wikis are generally cost-effective, often free, or very affordable, which is great for large teams, maybe with volunteers too.
Okay, but if potentially anyone on the committee can edit it, how do they maintain quality? Especially for critical stuff like safety protocols or medical information that needs to be totally accurate, maybe even translated correctly for different teams.
That requires clear rules and processes. Quality assurance policies are key. It starts with basics, encouraging people to verify their sources, maybe even attribute who provided specific info. You need to know the currency. Is this information up to date? Is it from yesterday or last year? Then you need moderation. Maybe certain critical sections require review or sign-off before changes go live.
Like a mini approval process within the wiki.
Sort of, yeah. And checking for validity, making sure information isn't biased. Ultimately, you need to foster a culture where everyone feels responsible for maintaining accuracy, maybe provide some training on how to evaluate information critically.
That sheer amount of information, both from the race and internally, leads us to a really common problem today: information overload. Can you define that for us and explain why it's such a challenge for making good decisions?
Sure. Information overload is, well, exactly what it sounds like. It's that feeling of being completely swamped by the sheer amount of information available, too much data coming at you. The challenge isn't just the volume itself, it's that it becomes incredibly hard to filter it all, to process it effectively, and figure out what's actually relevant and important.
Yeah, you can't see the wood for the trees.
Precisely. It makes decision-making really difficult. You struggle to manage the information flow, and you might miss crucial details or just get paralyzed, unable to make a choice.
Oh, that is so relatable. For students listening, think about researching a big project, like your IT PATE. You search online and boom, thousands of results. You get overwhelmed trying to figure out which sources are good, which are current, or you just get distracted clicking link after link and end up achieving nothing. That's overload in action.
Exactly. And the Marathon Committee faces the same thing internally. They can't possibly have staff manually read every single email or operational update. They need smart technical solutions, maybe advanced email filtering, a really good internal search engine that ranks info well, structured ways to tag and categorize data just to cope and avoid that decision paralysis.
Speaking of paralysis, let's talk security threats again. The organizers have all this valuable race data, participant info. They have to keep it safe. Let's hit two big threats. First, spoofing. What is that, and why is it dangerous here?
Spoofing is basically digital impersonation. An attacker creates something, an email, maybe even a whole website that looks exactly like it's from a legitimate source.
Yes.
So it might look like an official email from the marathon organizers, or maybe a message from a big sponsor, but it's fake.
A fake front.
Right. And the goal is usually to trick people into clicking malicious links or giving up sensitive information like login details, credit card numbers, that kind of thing, because they trust the fake source.
And the damage isn't just stealing data, is it?
No, absolutely not. If a big spoofing attack targets marathon runners and successfully tricks a lot of them, the damage to the marathon's reputation is immense. Runners lose trust completely. They might not sign up next year. There could be lawsuits. It undermines the entire event's credibility.
Okay, nasty stuff. Second threat, ransomware. We hear about this a lot. Malware that locks up your files until you pay up. Why do these criminals always seem to demand payment in cryptocurrency?
Yeah. The main reason is anonymity, or at least pseudonymity. Cryptocurrency transactions, unlike, say, bank transfers, are much harder to trace back to a specific individual or location.
Harder for law enforcement to follow the money.
Exactly. It gives the criminals a layer of protection, makes it much harder for authorities to identify and catch them. It's unfortunately become the preferred payment method for this kind of digital extortion because it's difficult to track.
Makes sense from their twisted perspective. Okay, last practical point.
Yeah.
Software updates. We all know they're important: new features, security patches, essential stuff. But what about automatic updates? We just click yes or let them happen overnight. What control are we giving up? What are the actual downsides we should be aware of?
It's definitely a trade-off. Convenience versus control. On the user side, automatic updates can be pretty disruptive. First, they can suddenly chew through a lot of your internet data without warning, especially if multiple big updates happen at once.
Right, it could be costly on mobile data.
For sure. They can also slow your device right down while the update is installing. And then there's the classic unwanted restart. your machine just reboots itself, maybe when you're right in the middle of something important.
Oh, the worst.
Yeah. And from a more technical or system management point of view, the risks can be bigger.
Bigger than just inconvenience.
Oh, yes. Auto updates might install features you don't want or need, taking up space. More critically, they often don't have easy rollback options. So if an update introduces a major bug or breaks something, you might be stuck. You can't easily just go back to the previous stable version.
Oh, okay. No easy undo button.
Right. And probably the biggest risk, especially for an organization like the Marathon Committee running complex, interconnected systems, compatibility problems. An automatic OS update might suddenly break compatibility with essential software that hasn't been updated yet to work with the new OS. That could cripple critical operations. Potential for data loss, too, if something goes wrong mid-update and wasn't backed up.
So what does this all mean? We dove into a Marathon's tech setup, and it really highlights this complex web of integrated systems full of risks and necessary trade-offs. We saw that website security isn't just about basic encryption, it's about that whole chain of trust verified by certificate authorities.
And we connected things happening locally, like RFID tags, reading times, or low-power sensors and wearables, to these big background systems using distributed computing to handle delays and prevent failures. We saw how every efficiency gain, whether it's automated timing or real-time collaboration using a wiki, brings its own set of security worries or data management challenges. Information overload, spoofing, ransomware, they're all part of the picture.
So the final thought we want to leave you with really builds on that idea of connectivity versus control. Think about it. If distributed computing is so powerful that it helps manage your watch's processing, prevents data loss across the network, maybe even optimizes battery life, does that interconnected system start to gain a kind of inherent control over your data and maybe even influence your actions?
Yeah, it's a fine line, isn't it, between a system that serves you conveniently and one that subtly starts to dictate things because it's so deeply integrated. It's about that power dynamic, something to maybe mull over next time you connect a new smart device or just blindly hit accept on that next big software update. Where does convenience end and control begin?
Definitely food for thought. Apply these ideas, understand the integrated risks in any system you study or build, and you'll have a much better handle on the reality of modern IT. Thanks for diving deep with us today.
If you found this podcast useful, then firstly go to the video description and go check out the other podcast links over there, and make sure that you subscribe to the channel so you don't miss when we post new podcasts at Mr. Long Computer Terms. And remember, don't do it the long way, do it the Mr. Long way.